Hello there, everybody. This lesson is an introduction to trig ratios, and may not know what those are yet, but you again soon will. Before we get to those, let's start with talking about similar triangles. The question is, are these 5 triangles similar? Well, there's 3 ways that we figured out if triangles were similar. They were angle-angle, side-side-side similarity, and side-angle-side similarity. And these are all 5 triangles. All these are similar because they all have right angles and they all have 11-degree angles in them. So they are all similar. That means the ratios of the sides have to be the same too. And we can see here that this side is 1 and this side is 5. And that if we make a ratio out of those two, we get 1/5. This side here is 2. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The ratio of those two sides is 2/10, which is 1/5. Same ratio as we got on the first one. For this triangle here, this side is 3. This one is 15, and you can count if you don't believe me. We make a ratio out of that. We get 3/15, which again is 1/5. This side here is 4. This side here is 20. Again, count it if you want to check. But it is 20. And we make a ratio out of those. We get 4/20, which is 1/5. The ratios of those two sides is the exact same for all of those triangles. So anytime we have a triangle with an 11-degree angle and a 90-degree angle in it, we know that the ratio of those two sides is always 1/5. And we can use that in this triangle, right? We can set up a proportion because we know that if we go x over 12, that has to equal 1/5. Now, how do you know which one to put on top? X or 12? Well, in all these triangles, the side that was opposite the 11-degree angle went on top. So here, 1 is the side that's opposite the 11 degrees. It was on top. 2 is the side that's opposite the 11 degrees. It was on top. 3 is the side that's opposite the 11 degrees here, and it's on top. 4 is the side that is opposite the 11 degrees, and it's on top. But the side that's opposite this 11-degree angle goes on top. So that's why I got the x up here. And now that we've got a proportion, we can just solve it. 5x equals 12. Divide both sides by 5, and you get 2.4. And there is the length of our side. Now, that's great as long as we've got a right triangle with an 11-degree angle in it. But there's all kinds of other angles that these triangles can have. Even if we just say we're dealing with right triangles, this angle right here could be anything from, just above 0 to just under 90 degrees. So what is that ratio of that opposite side to this other leg for all those other angle measures? What is it for 18 degrees? Or for 62 degrees? What is it? Well, it turns out that your calculator will do that for you. And the button on your calculator that does that is called tangent. And you can see on this calculator, this is a graphing calculator, but any scientific calculator will have this button on it. It looks like tan. It's short for tangent. And it's just going to give you the ratio of that opposite side to the angle and the side that's next to it, the side that's adjacent to it. So if I want to know what it is for 18 degrees, I just hit tangent of 18. Now, if you're using whatever kind of calculator you're using, make sure you are in degree mode. It is very, very important that you are in degree mode. Just like distances have different units of measure, you can measure distance in inches or centimeters or meters or yards. You can measure angles in different units as well, and they're called degrees Another measure is called radians. Another one is called gradians. There are different measures for angle, or different units of measure for angles. You need to make sure you are in degree mode. If you have a calculator like this, you'll hit the mode button, and you'll see that right now I am totally in the wrong mode. I am in radian mode. So I need to go over here and hit enter so that now I am in degree mode. If you have a regular scientific calculator, it'll either say DEG in the normal kind of home screen that you have, or it'll say nothing. If it says something like RAD, R-A-D, or G-R-A-D, you are in the wrong mode, and you need to figure out how to change it. Again, in that home screen, in a scientific calculator, you want it to either say DEG for degrees or nothing at all. So I'm going to go back to my home screen. So tangent of 18, already got that in there. That is going to tell me what that ratio is, and it is 0.3249 about. So I know that for this triangle, 0.3249, and again that was the tangent of 18 degrees. And now again the side that goes on top is the side that's opposite the 18 degrees. So in this case that's 4. And the other leg of the right triangle, not the hypotenuse, but the other leg goes on the bottom. And so I know that tangent of 18 is 0.3249. I can put that over 1, and now I can cross multiply. So we got 0.3249x equals 4 times 1 is 4. Then I divide both sides by 0.3249. Divide by 0.3249. I get x equals, let's see here, 4 divided by all that stuff, about 12.3. And there is the length of that side. Let's look at this other one. Again here, we're going to use tangent of 62 degrees. That's going to give us the ratio of these two sides. And on the other side, the side that goes on top is the one that's opposite the angle that you're looking at. So in this case, that opposite side is 5. And the other leg, not the hypotenuse, but the other leg goes in the other place. In this case, it's x. So now we figure out what tangent of 62 is. Tangent 62. That's going to tell us what that ratio is. It's 1.8807 and some more. So 1.8807. We can even put that over 1. Equals 5 over x. So 1.8807x equals 5 times 1 is 5. We'll divide both sides by 1.8807. 1.8807. And we get x is about, let's see, I want to do 5 divided by that. About 2.7 if we round to the nearest 10. 2.7. And that is the basics of tangent. The next video you'll watch will show you what to do when you have information about the hypotenuse of the triangle.